want to introduce Martin Luther, VK7GN, who you probably well know in global contesting circles. In fact, Martin's probably knows more about contesting and has been contesting for longer than most people in this room, I think, and probably for more than most people who have been licensed as well. So welcome, Martin, over to you.
I want to talk, first of all, a little bit of philosophy. If you want to contest, the last thing you need is your station to fail just when you're about to post the largest score you've ever made. And it does happen. There's a guy called Murphy, and he's very much alive. So that I want you all to think of it as a system, and designing a system that hopefully will not fail very often. Analyze it like a professional engineer would, whose career probably depends on getting it right. So let me use some examples. I'm often told that I don't need a kilowatt amplifier for 400 watts. Okay, you've heard of the KISS principle? Keep it simple, stupid. There's a corollary to that. The world is full of simple solutions that are just wrong. And that's one that's just wrong, because they're not thinking of what the problem is. The problem is not the power. That's almost irrelevant. The problem is expressed in a thing that was invented years ago called ICAS, Intermittent Commercial and Amateur Service, developed by the manufacturers of transmitting tubes so that they could sell a 60-watt tube as a 100-watt tube, as long as it wasn't used continuously. But importantly, if you're operating in a contest, running 3 stations a minute with compression on the SSB, you are very close to running it continuously. The problem with running continuously is the heat doesn't dissipate. And having seen tubes that have got so hot the glass has softened, they make a brilliant sculpture, but they're not much use for RF after that. So the 2 things that you're looking for are reliability and the problem with heat, and that is on the power supply and the tube. I'll talk some more about that a little later. Just an example in antennas, you do your calculation on how big the antenna is, what its wind loading is, how that affects the tower, what the breaking strain of the rope is that you need to hold it up, and then you go down Bunnings and buy some D-shackles and built in a backyard in China somewhere. If you're doing it properly, use the proper equipment. Okay. Technological forecasting, looking at the future. What's going to happen in the future? When I was doing my master's degree, I did a thing on technological forecasting, so I do know a little bit about it, more than I think I really want to know. But forecasts are nearly all based on the past. There are disruptive technologies that occur which you can't forecast. But everything else is just an extrapolation of the past, up to about 5 to 10 years. There's nothing new created within 5 to 10 years other than a massive disruptive technology. So we know from the past what's likely to happen in the future. We all love a good radio. We want to hear and generate RF. It's all simple. But the needs change over time. If you look at receivers just past World War II, they had a lot of gain in the front end, often 2 tubes in the RF stage. And that was because signals that they were listening to were very weak. Sensitivity was most important. And they didn't have a lot of big loud signals coming in to the receiver. After World War II, we got the idea that we needed to distribute the gain through the receiver. Art Collins of Collins fame was the first guy to do a lot of useful work on that. In the 1970s and onwards, the mixer became the critical device. And we had all sorts of designs of mixtures. I thought it might be instructive to look at 3 radios from the period when I was first licensed in 1966 to radios that are sitting on that bench over there. One's an introduction radio, one's an intermediate, and one's a top end. It's interesting that as the digital revolution occurred, and we tried to get analog to digital conversion directly from RF to digital, the problem at the front end of the receiver went all the way back to those receivers after the World War. And you had to drive them the same way. Leave the AF gain at control alone and reduce the RF gain to stop any overload. Okay, here's two entry receivers. Swan 350 from the 1960s and the IC 7300. Looking at the 7300 from the 1960s, it's science fiction. It literally is science fiction. We also had a cartoon character in the 1960s called Dick Tracy. And Dick Tracy could talk all around the world on his wristwatch. And we thought that was really, really cool and was never going to happen. Let's look at the cost. I've taken the cost and I've used extrapolation into today's dollars. The Swan in today's Australian dollars would have cost you $5,000. You can buy the 7300 even at list for $1,875, and I noticed one retailer has got it a lot less than that. And the facilities and abilities of that radio are just dramatically ahead. So when you start complaining about the cost of the radios, you've got to be kidding. And it was very noticeable in those days. The Drake, the TR3, it's an intermediate radio. Compare it to the 7610, also an intermediate radio, $9,000 to $5,000. And with some of those 1960s radios, you didn't get a Vox built in, that was an extra. A Collins S-line would have cost you $23,000. $23,000. How would the most like that? 7851 these days cost you 22. You used to be able to buy them a lot less than that, but never mind. The new 7760 over there costs about 10. The older radios produced reasonable signals and heard them okay on a good day. But the modern equivalents of facilities that can produce exceptional signals and resolve reception out of noise. I think the noise features of digital are the most important. What do we discern from this? A to D conversions will get faster and new designs will address problems created by overloaded front end. In fact, that radio over there now has multiple front end filters, and each of those filters is directly linked to the tuning, so they're tuned right on the nose to keep as many of the big signals out of the A to D converter as possible. Anand has already proposed a 1 kilowatt transceiver. With the LDMOS style transistors, you can now put an amplifier in a box. There is a problem with that, of course. And we're back to my earlier comments about heat and cooling. That an LDMOS is even more critical on cooling than is the old valves. Noticeable that Icom on that new box has separated the front panel from the electronics. Now, one of the things that really annoys people about linears is the sound of the fan. In fact, there's the odd idiot that keeps on replacing his fans with more quiet fans, not realizing he's probably reducing the lifetime of the linear, but never mind. That separation then allows them to put in that box more cooling fans. It allows them maybe to add a linear which can go around the back, and you've got just one control panel for all of your radio and your linear. Both that and the anans have a thing called clean signal. I don't know whether you've heard about this, but what they're trying to do now, we've cleaned up the front end of the receivers. We've got the receivers so they're not susceptible to a lot of noise and overload, but we've done absolutely nothing about transmitters. And a lot of transmitters are really fairly flaky. What this does is provides a sort of feedback mechanism from the linear back into the radio, and it tidies up the passband of the stuff going out. And it does work. I've seen a couple of guys playing with it, turning it on and off, and there's no doubt about it. It cleans up all the fuzziness around the outside of the signal. Now, the downside. The downside of the modern radios is that I can't do what I could do with the old Swan 350. In fact, I've got one in my history collection, and I do it. You can fix it up. There are still valves available. There are transistors and resistors and so on available. You can make it work. But in these modern radios, they often have very dedicated chips, which the manufacturers stop after about a 2, 3, 5 years lifetime. They become redundant, and you just can't get them. So that radio then is junk box material. It's not going anywhere because it'll never work again. The next thing that you ask is how many, if you're going to do all this with the box and you've got a separate front panel, how many bands can you put in one box? I'll leave you to think about that. Looking at antennas, the basics of antenna theory have been known for a long time. If you look at an old antenna book going back into the 50s and 60s, there won't be a lot of difference between that and what you read today. They did some pretty good work back then. Good example is the high gain 204. You can put that through a computer model and it comes out very well indeed. But they were working with slide rules and an antenna range. Computer modeling allows us to do a lot of experiments without a full-sized or computer model range. So what has changed? Test equipment has changed. At the bottom there is a General Electric bridge, which weighs half a ton. There's no way you're taking it up the tower to find out what's happening to the antenna up there. Very accurate because it's really a laboratory instrument. Works up to about, if I can cheat a bit and look it up, goes to about 20 megs, I think, but I won't swear to that. The little black thing up the left is an Autech. That was the first of the computerized measurement systems. You had one for HF and one for VHF. Up the right here is a noise bridge. They were very handy. They've been around for a long time. Not very accurate, but it gives you a good idea of what the ohms are in the impedance measurement and whether it's a plus or minus, so whether you need to put some capacity in or some inductance in. But then you move to these things like the Reg Expert stuff, and we're talking here about the little tiny thing on the left goes from 600 kcs to 230 megs. It's quite accurate, and it has a display which you can actually read in the sun. Fairly unique in modern displays. The big blue thing in the middle, it goes from 100 kcs to 1.5 gigs and can measure SWR, impedance, time domain, reflectometry, blah, 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 blah. An absolutely indispensable piece of test equipment if you are wanting to build a good antenna system. Compact antennas, there's a limit to how small you can make an antenna. Physics just limits what you can do. But there's been an emphasis on stuff like Moxons, small loops, small end-fed wires, coax off-center fed dipoles, and the hex beam, which is basically a two-element Yagi anyway. Limits on physics will affect how far we can go in reducing size. Contesters and DXers will always look for the best gain at the right angle of radiation, maximum efficiency to make sure every watt is radiated, and the biggest and highest, of course. For bigger antennas, see this topic. There's a growing trend to remote operations. Planning issues and received interference make city operation with anything like a reasonable HF antenna very difficult. Satellite systems such as Starlink make remote operation feasible from sites where real estate is cheap. I actually have a 4G link at my remote station, but it could be this. Where the biggest change in contesting has occurred is in the actual operating procedures. Contesting BC, before computers, was all handwritten logs. That's one of mine from somewhere or other, 1978. Entries were posted, postmarked no later than 2 to 3 months after the contest. And you got the results back, usually in a magazine, which often arrived in Australia about a month after the next year's contest. So all those who complain about not getting the results of the contest within seconds, think of that. And it's probably why I really don't take a lot of notice of the results. But for me, operating contests is just about having fun. Later entries were on floppy disks. I suppose the young people don't remember floppy disks, but they were actually floppy. And then we had 3.5-inch disks. But that didn't mean the log was computerized during the contest. It was done post-contest. It was entered into the computer. My first one was a TRS-80 and gradually developed up from there. But before computers, we had this. So this is a book, and these lines are actually pieces of cord, cotton, going up and down over cardboard. You can slide a piece of paper in there. And then Linda and I used to spend many happy hours, me reading out the log and she entering that in there so we didn't get any duplicates. Because in those days, if you claimed a duplicate, you were penalized up to 5 contacts. So it was quite a big penalty, and log checking was essential. Then computers came in and we could get the stuff printed out properly and legible. Full operating log systems, that is the thing we know today, of where you sit and operate the keyboard while you're running the radio, was started by CT. I think there were some other minor ones before that, but the main one was CT by K1EA. He's still around, and he writes a lot of the software for the checking people. N6TR followed in about the late 1990s, and I used CT for a while, but I converted to N6TR and I still use it. More recently, N1MM was created and has become the main logger used by many contesters. Now, the log checkers also benefit from computing. There's software that cross-checks all QSOs and scores the remaining log after removing dupes, etc. So, you put in your log in digital form now. If nobody's interested, I've transcribed a lot in the Oceania contest of handwritten logs and transcribed them into digital so we cross-check them. But nobody's really interested in doing that anymore. But all of the logs go into one great big giant database, and then they are all cross-correlated. And they're rescored by the software, and the software produces a thing called a UBN report, which The B stands for broken, and the N stands for not in the log. I forgot what the U stands for now. Unique, sorry, unique. Unique, broken, not in log. So you get that printout which shows you where you've made mistakes in your logging. Now all this is computer generated. So where to next? Computers are getting more powerful. Internet connections are getting faster and available from more places. There's things like the reverse beacon network, skimmers, and supercheck partial databases. They'll all expand. There are live scoreboards now, so you can see how your score is working against the rest of the world. And some wish to make this more like a computer game, so it's all interactive all the time. Now, I see a bit of a problem with that, in that with my remote station, I've got a monitor for my log. I've got a monitor that's got the antenna switching, the linear, the rotator on it. Am I going to put up another monitor over here, which has got live scoreboards or whatever else it is that people want to have? And where's my concentration going to be? If I really want to be contesting properly, I'm operating two radios at the same time, one on that ear, one on that ear. Have I got time to look at? Don't think so. Well, maybe a younger person does, but there we go. Now, looking a bit about DX, I don't know whether you picked up that the shack-in-the-box approach to the expeditions. What this is that they've created a whole station that can be taken on a boat and put on an island, and it's particularly useful where there's restrictions due to the environment or whatever. And it's been used recently, and the operators can be anywhere in the world. They operate this thing remotely. It's on the island, it's on the DX location, the operators aren't. I think new digital modes will happen. How about digital inside audio? We could perhaps have our identification on our transmitter the whole time. That might get rid of some of the carriers that we put up with. And in fact, it's more than feasible in the digital world. It was done by NASA in the analog world. Some of the early space shots, they had one of their data channels was on the same channel as the voice channel. And they used filters to filter out a little bit of the voice channel to use for the data transfer. And you could tell if you were listening that it wasn't a full bandwidth voice, but it was quite legible and quite okay. But I think with digital, that could happen. Maybe digital voice allows that to happen. I think the live scoreboards will continue to develop, and I think that they'll become more specific so that if you want to compete with your mate down the road, you can both have your scores up, but not anybody else's. Rigs will continue to get more clever with filtering and more facilities in the one box. And I think they'll continue to get cheaper in real terms. So they might not look cheaper because we've got inflation and all that sort of stuff, but in real terms, they'll continue to get cheaper and they'll get more and more stuff in them. But they'll also get more and more susceptible to unrepairable faults. I think that's the biggest downside of modern technology. Portable operation is going to grow as home operating gets more and more difficult. One of the other things I think will happen in contesting is I think we'll see more and more shorter contests. That people are time poor and they're also getting older. And I can't do 48 hours any longer. I simply can't sit in the chair for 48 hours. Just won't work. I'm going to fall out on the floor at some point. So I think we'll see shorter contests, more like the sprint contests. But anyway, what do you guys think will happen? Over to you.
Now, questions for Martin. Very thought-provoking, I thought. So, any questions? Oh, right up the back.
Thank you. Great talk. I was just wondering if you thought that as all this technological development has happened, that there's kind of a call for kind of stratified contesting, because now you get people who might be using automated band scanners and optimization models to try and pick who they should try to contact and things like that. And you might be individually very interested in using older technology, and now you're trying to compete on the same fields. Do you think as we get more and more options for people to be operating, that there will need to be smaller groups who want to compare their contest scores against people who have similar setups?
The effect of operating, of technology on operating, there was one of the guys, N6TR, that wrote one of those softwares, actually wrote a program to do a CW contest while he wasn't there, right? And it didn't win, but it did pretty adequately. And once the contest was over, he erased all trace of it and said, why would you bother? The only point of doing a contest is because you want to do the contest. If you leave a machine to do it for you, and I think that applies to a lot of this new technology, if you're not careful, you're leaving the machine to do it for you. I think that's starting to happen with digital operating. That the kind of work that Rex does is on a completely different plane to operating FT8 on 20 meters. And I think I've got little or no interest in having my computer talk to your computer.
Any other questions?
Thanks for the talk, Martin. Just wondering, because I know you do a lot of work on CW, do you think CW's got a future in contesting going forward?
So I didn't catch that, did you?
Try again. Try again, Lee.
You've done a lot of work with CW, I know. Just wondering if you think that CW has got a future going forward in contesting.
It's growing all the time. And the absolutely fascinating thing is the number of people I now work on CW that were absolutely violently opposed to the retention of the CW test to become a radio amateur. I mean, you know, there are people who were actually vitriolic about it. And I now work them on CW, on the radio. It is growing all the time, and it's something that actually fascinates the young people much more than just talking on the radio. They can talk on the cell phone anywhere in the world. But Morse code is a secret code that only some people know about, and that works pretty good.